In the last part, the Genial cell gave us a reading of about 1.1 volts. Where does that number actually come from? The answer is electrode potential. Think of it as a yardstick that measures the push of each electrode. Take one zinc rod, all alone, dipped in a solution of its own zinc 2 plus ions. Bomb zinc atoms leave the rod and go into the solution as zinc 2 plus ions, while their electrons stay behind on the rod. But at the same time, some ions take electrons back and redeposit on the rod, so the two flows soon reach a balance. That balance leaves behind a charge gap. The rod becomes negative, and the solution right beside it becomes positive. This separation is the electrode potential. Every metal has its own push, so every metal has its own electrode potential. A voltmeter always needs 2 points to read a difference, so it can never measure one electrode all by itself. It is just like a mountain's height. They always measure it from a fixed zero, which is the sea level. But we fix one common reference electrode at zero, and then compare every other electrode against it. The reference we chose is the Standard Hydrogen Electrode. Let us build it, piece by piece. Step 1. Take a platinum strip, coat it with rough platinum black, and place it inside a glass tube. Step 2. Dip it in acid that contains hydrogen ions at 1 molar, a fixed standard amount. Step 3. Bubble pure hydrogen gas over it at 1 bar pressure and 298 Kelvin. These fixed conditions make every comparison fair. On the platinum surface, a hydrogen ion plus an electron is in equilibrium with half a molecule of hydrogen gas. This reaction runs both ways. Diplatinum, because it is inert, it adds no potential of its own. Zinc, for example, would dissolve and spoil the reading. Platinum does two jobs. It is a meeting surface where the gas and ions react, and an electron gateway. The rough platinum black grips the gas. By agreement, the Standard Hydrogen Electrode is fixed at exactly 0.00 volts. This is our zero mark. Connect any electrode to the Standard Hydrogen Electrode, and now the voltmeter finally has its 2 points. Read it under standard conditions, that is 1 molar, 1 bar, and 298 Kelvin. This gives the standard electrode potential, written as a standard. The cell potential equals the right electrode minus the left. The hydrogen side is 0, so the reading itself is the electrode's potential. The standard electrode potential is always written for the reduction direction, so all the values share one common scale. Hopper against the Standard Hydrogen Electrode reads plus 0.34 volts. The reaction is the copper 2 plus ion plus 2 electrons gives copper. Because the value is positive, the copper 2 plus ion grabs electrons easily, so copper will not dissolve in hydrochloric acid. Zinc against the Standard Hydrogen Electrode reads minus 0.76 volts. The reaction is the zinc 2 plus ion plus 2 electrons gives zinc. Because the value is negative, zinc gives away electrons easily, so hydrogen ions can dissolve zinc. Each metal now has an exact number. Negative means it gives electrons, positive means it grabs them. Thanks for watching. Like and subscribe to Baidyati. Electrochemistry, last 12 chemistry in English.